So I'm Ludovic. I'm going to give you an update on the RISE project and how we are working to advance software on RISC-V. Unfortunately, Nathan couldn't make it to the summit, but thank you to him for helping putting that together. So, what is RISE? And why do we exist? RISE was created, I believe, 2 years ago. We actually did our anniversary just a few weeks back. Because we noticed that there was a lot of RISC-V hardware vendor who were getting together, or actually not so getting together, investing in different projects, for example, QEMU, LLVM, GCC. And it turns out they were kind of doing the same things on this project. So they ended up having competition upstream, which is not always very useful, especially as there's so much work to be done. So RISE was really created in that objective of getting multiple vendors together to collaborate and contribute to the upstream community, to really still invest heavily in the software stack fundamentals, as we are going to see a bit after with, for example, QEMU, the kernel, GCC, LLVM, and many others, but also to really foster this community effort of continuously improving the software. As we probably know, there's still a long way to go. So what are we doing specifically? We're really trying to raise the platform quality of every software out there on RISC-V. We're making sure that RISC-V is really a top-tier supported platform on as many software as we can out there. Again, from the last level, like OpenSBI, firmware level, QEMU, GCC, kernel, all the way up to Python, Java, and many others. And we're really also trying to align the ecosystem, so making sure that the many software ecosystem out there, many software communities are working together, are aware of RISC-V, and are porting their own software to it. Really the key to RISE ethos is to really work upstream. Where RISE is not interested to have forks, because forks are only useful to us, and we really want to make it available for everyone. And we're working as transparently as possible by working directly to the upstream communities. RISE is made of many members, so thank you very much to everyone. Many companies from Intel, Google, Samsung, Rivos, Red Hat, and these. Any RISE member is also an RVI member. That's really a key tenet to what we're doing. So thank you again to everyone here. Let's dive a bit deeper on what exactly we're investing in. As mentioned before, because we expect that end customers are going to come and buy any vendor's IP or end product, like for example, the i5 P550, the Banana Pi, and many others. End users expect things to just work, right? That's kind of the big challenge. So for that to just work, there's a lot of things that need to be brought up, be efficient, be optimized, and be available. So we are investing in a lot of these projects. So from LLVM GCC, for example, Linux, the kernel, QEMU, U-Boot, developer tools, PyTorch, just to name a few, right? But you can see how wide, how deep down the stack, and how high up the stack we are contributing. All of that, we're doing it in the open again to the upstream communities, but we're also tracking the work we're doing on our wiki, on which you can find the link at the bottom of the slide. One of the latest additions we have is the AI/ML working group. One thing we noticed, it was great to invest, for example, in GCC, kernel, distributions, but one key workload that seems that everyone in the room cares about is really AI and ML. We did identify a few projects that was really cool for us to contribute to and are not available on PyTorch, on RISC-V. For example, PyTorch, to which we went to there's a PyTorch conference nowadays, so we did go there. We talked to the maintainer of PyTorch, some of the core contributors, and figured out, okay, how can we bring PyTorch to RISC-V, for example? But again, upstream PyTorch to RISC-V. We're also investing in, for example, OpenBlast, because it's a key dependency of PyTorch. We are investing in Llama CBP, we're investing in IRE, all of that to try to figure out, okay, how can software which are used by our end customers useful, and available out of the box on RISC-V. This is really, again, the core things we are doing. Some of the work that we have been doing, and that I just wanted to highlight some of the results. We did invest a lot in LLVM, for example, working with Igalia. Thank you very much to all the work. Optimizing spec on the Banana Pi specifically. Banana Pi mostly because it's a widely commercially available board, not necessarily representative of like high performance servers, but until we have high performance servers available, we're going to keep using what's commercially available. Here the work was really on improving vectorization, better register allocation, and other like really just broad code generation optimization in LLVM. We have worked with the Go community upstream to make it available on RISC-V. So we did expand support for vector with bin-banip. Compressing instruction patch was submitted a few days ago. It's in review, but should be integrating very soon and be available in the next version of Go. But Go is available since 1.21, which is a year and a half ago. It's now available on RISC-V. We also invested a lot in Python packages. So this is, for example, something we identified, right? Of if any end users wants to install PyTorch, the problem is Python dependencies, NumPy, for example, Pandas, for example, are just not available on RISC-V for multiple reasons. First of all, the tooling, like the tooling to build and distribute, was not available on RISC-V. So we did work with Alma Linux, for example, which is a core dependency of that, for them to enable it and to distribute Alma Linux on RISC-V. So this is done with Alma Linux 10. Next, we went up the PyPay, so Python Packaging Authority, which is the group taking care of all of the Python build tools. And we made sure that they provide a RISC-V package, right? And then we went up the stack, and now we're contributing to NumPy, for example, or any of the other projects to make sure that they do package and distribute their project on RISC-V, right? And so we are slowly enabling everything. In the meantime, we are also providing packages, right? So that we make sure that anyone who wants to install PyTorch today, it just works like the packages are available. So this is really investing at every level of the stack to make sure that everything just works for the end user. Also investing in QEMU, for example, to make sure that whoever is using it for testing on CI or anything like this, it's faster. QEMU it's great, but it's not that fast. Investing in Rust to make sure that the language is available on RISC-V and distributed from upstream directly. Investing in OpenCD, investing in LLVM CI, in GCC CI, and many other projects. Investing in project directly, so for us to basically put the engineering resources or the money for the projects is great, but what you also identified is we want to enable and engage developers out there whose day job is not necessarily RISC-V stuff, but we want to help them port their software to RISC-V. So for that, we have really identified 3 core tenets. The first one is resources. A RISC-V optimization guide, for example, case study on how to write efficient RISC-V code using vector, developer images, so people can easily have the latest and greatest tooling on the different boards that are available, Python packages, for example, so that they can just install, the dependencies are working. That's the first part. We also identified that CI is a big missing piece because people just don't have easy access to RISC-V. The only way for them usually is go to AliExpress, buy a board, wait for it to be shipped, have it running on the desk. It's not ideal, right, for every developer out there. So we're really trying to fill that gap and make a board available to them, or even GitHub and GitLab runners available for them, ideally for free. And we're also investing in the communities directly. So we have the developer appreciation program, for example, which I'm going to talk about. We have the RFPs, which I just mentioned a few. And we're also investing directly in some of the projects, Yocto, for example. So let's dive a bit deeper on that. One key investment that we have is our developer infrastructure working group. Some key items here are the build farm. So this is really a cloud machine, x86 ARM64, that we are using to build and test existing projects. For example, kernel on GCC, These numbers are from a few months back, so you can count that the numbers are actually going up. We already found more than 137 bugs in GCC and fixed, right? All of that thanks to fuzzing. So generally speaking, GCC is just getting better releases after releases. That was with like 800 post-commit builds, so you can imagine how many cycles that took, and a lot of patches being tested and making sure that GCC does not regress on RISC-V. A lot of these bugs were affecting spec directly, so making sure just like spec is faster, spec is less buggy, spec is basically working better on RISC-V, generally speaking. Another bit is the bolt farm. We have been working with Scaleway. Fabian is in the room, thank you very much again, with their amazing RISC-V offering, which is you can just go to a cloud, ask for a bolt, and you have a RISC-V machine available. We have been using that with different programs, or different projects like Eclipse Adoptium, which makes Java distribution freely available. And with them, we have enabled Java 17, 21, 25, which are the latest NTS. Just make them available for free on RISC-V. We're also using it with Go, we're using it for Rust, we're using it for Python. We're really trying to make it as widely available as possible. The next step, which we are working on nowadays, is to provide GitHub and GitLab runners so that any developers who has a GitHub or GitLab project can very easily have a runner for free on their CI. So if you are familiar with GitHub, for example, you can have x86 and ARM64 runners for free, right? You just push a YAML and you have a runner for free. The idea is to complement that for people to have a RISC-V runner. We expect that this is really going to enable more projects, because whenever we go to contribute to any project up there, the first big bug usually is, I don't have RISC-V hardware, how am I going to test it, right? So this is really the gap that we're trying to fill. It's great to have machines, but people like money. So one thing that we're really trying to do is to reward external developers, so developers who are not working in the RISC-V ecosystem every day, and tell them, hey, if you port your software to RISC-V, even without asking us or synchronizing with us, we're going to give you money for that. So it's as simple as filling up an issue on github.com RISE Dev Appreciation. If you have projects that you ported to RISC-V, please fill it up. To give you an example, so just to be clear, they did not synchronize with us beforehand, right? They just came to us, we verified the work was done, and we sent them the money, right? There was no synchronization. It's really a way for us to show our appreciation and encourage more people to port to RISC-V. So it's pretty wide, right? From Gem5, some vector optimized libraries, some Cisco user space interception of system calls, portable CMD library. The breadth is pretty large on what was done, but we see that as progress because any software out there which is made available on RISC-V just help lift the whole ecosystem. If you have any friends or anything who do write software, please tell them about that. We do want to give them money. Another example of what we're doing is developer images. So it's based on Gen 2, and here the idea is for any RISC-V boards like the K230, Banana Pi, Orange Pi, we want to make it easy for anyone to have access to the latest toolchain. For example, latest GCC, latest Clang, latest Rust, latest glibc, all of that so that they can test the latest and greatest. It's also with the latest firmware, kernel, U-boot, OpenSBI, and Linux, and is built with also the latest optimizations. All of this is to help developers figure out, okay, how fast can my software be run on the latest of everything? And encourage them to port and test and optimize their hardware on that, or the software on that. If you have a dev board that is commercially available and you would like us to support it, just come talk to us and we'll be happy to generate the images for that. Another example is RISE has partnered with RVI to support and to help maintain the Yocto project. For those not too familiar with Yocto, and I may be wrong, I'm still discovering a lot about it, but it is It's a tool that allows you to generate embedded Linux images, so that if you have, for example, in the automotive industry, or you want a Linux-based distribution for your use case, then you can use Yocto to generate that. Here, RISE and RVI have partnered together to really push this project forward and make it available on RISC-V. We are also partnering with Bay Libre to have a maintainer that is paid by RISE and RVI, and making sure that Yocto is a fully supported project for RISC-V. Other developer resources that we have an optimization guide. So this is just run-of-the-mill guide on what is the generally acceptable best way to write optimized code. So there is, of course, a pretty large section on vector code. Contributions are absolutely welcome. There's always new sections that need to be added, always new macro optimization that needs to be done. So if you have ideas of how software developers can optimize their software for RISC-V, please go contribute. It's an open source project. We also have some case study on how to add vector code to David. It's an AV1 decoder, part of the FFmpeg project. Nathan has done a few presentations and videos on how explaining the process and what was some of the optimization is done for K230, for example, then Banana Pi and future hardware. Again, these Python packages, so which just makes available packages available on RISC-V. So here it's 49, but I checked just before, now it's at 68. So now we have 68 projects that are available on RISC-V. To give you an idea, PyTorch has around 15 or 20 dependencies. So, but PyTorch can today be installed on RISC-V out of the box. SGLang as well, VLLM as well. But we really looked, and VLLM has like 50 or something dependencies, but we are really trying to match everything so that anyone who is building a PyTorch, for example, if you are building a PyTorch for your hardware specifically, you can count that the dependencies are readily available. So how can you contribute? First thing is that RISE really is trying to foster open source contributions. This is what we really care about. We really care about contributing to upstream projects. We are contributing directly through the RFPs, for example, but we are also helping developers to contribute themselves via resources, via infrastructure, and we are really trying to activate the ecosystem. We are trying to go to other software conferences to show that RISC-V matters, that the software ecosystem exists, and that we have, and present all of the tools that they have accessible to them. And how can you get involved? You can become a member, of course. You can also submit to us RFPs. So if you have an idea of a software project that should be enabled, come talk to us. We'll scope it out and we'll figure out how to do it. And if you have already ported software, just submit again an issue on the github.com RISE Dev Appreciation, and we'll give you money for that. Thank you very much. If you have any questions, I would be happy to answer.